All right, this video we're going to look at annuities, method of saving, and investments. All right, so probably be a pretty long video, so let's go ahead and get started. It says an annuity is a sequence of equal payments made at equal time periods. And the value of an annuity is the sum of all deposits plus all interest paid. So basically what they're getting at, what you've learned so far is you put one lump sum into an account on some certain day, and then how much are you going to have after so many years? Well, with the annuity, you're putting so much money into an account at the end of each month. Okay, so like $200 at the end of each month. Or you're putting in $1,000 at the end of each year. Or you're doing it every 6 months or every week. You're making that same payment. Okay, the amount of the payment is the same at the end of each month, each week, or whatever. And how much are you going to have after a certain time? It's adding all those payments up plus the interest that you're getting. So let's take a look at example 1. All right, so let's see what we've got. So for example 1, it says you deposit $1,000 into a savings plan at the end of each year for 3 years. The interest rate is 8% per year, compounded annually. Find the value of the annuity after 3 years, and then find the interest that we made. Now, one thing that you might have noticed so far is we don't have a formula. In the past stuff that we've done in this course, we've had formulas for everything that we just plug in. Well, we're going to get a formula after this example. We're going to work this example out the long way, just this one. And then we'll look at a formula, and we'll start working these problems with the formula. One of the reasons I want to go ahead and work this out the long way is so I think it'll help you understand what's really going on, what's happening. Okay? And of course, the way that I'm fixing to work this problem, you're not going to want to work it like this. I mean, this is for 3 years that you're doing it. And then once we get finished with the problem, imagine if it was for 20 years, how long it would take you to work it. So let's go ahead and get started on this example. All right. So remember, it's payments at the end of each year. Okay, so it's all of those added up plus to all the interest. All right. So for the first year, at the end of that year, well, I might can write. Let me write that. Let's write end of year 1. Okay, at the end of year 1, we have $1,000. There's no interest to add. Okay, because let's say you started on January 1st, so you went all the way through that year, from January 1st to December 31st, and on December 31st, you put in $1,000. So there was no interest to calculate during that first year. Now we need end of year 2. All right. So how much are we going to have at the end of year 2? Well, at the end of year 2, well, we've got to calculate the interest, don't we? So you should remember the interest formula. So remember, that's going to be $1,000 times 1 plus RT, right? Remember, it's P times 1 plus RT raised to the t. I'm sorry, that's not the formula. 1 plus r to the t. Okay. Now this could be 1 plus r over n raised to the n times t, but in this case n is 1 because it's compounded annually. So it's just 1 plus r raised to the t. So 1 plus r, which is, let's see, what was it? 8% times 0.08 raised to the t, raised to the first power. Okay, that's the interest on this $1,000 here that we put in on December 31st. And then that whole next year, we're calculating the interest on that $1,000 for that year. And then we've got to add in the $1,000 that we put in at the end of the second year. All right. And then when you calculate that, you get $2,080. All right. And let's see, 1,000 times 1.08. Yep. So that's $2,080. Then we've got to do at the end of year 3. All right, the end of year 3. All right. So from the end of the second year to the end of the third year. Okay. See, from the end of the second year, that's what we're going to have, the 2,080. Now we go through the third year. Well, we've got to calculate the interest on that value. So that's going to be 2,080 times 1 plus 0.08 raised to the first, because remember, the interest on this 2,080, that's just for 1 year. Okay. And then we've got to add in the amount that we deposit at the end of the third year. And then when we calculate that, we punch that into our calculator, we get $3,246.40. Okay. So this is the amount of money we will have at the end of the third year for this annuity. Now, I mean, that was not that bad doing that, but could you imagine if we did this for 20 years? I mean, we would have to keep going, end of year 4, end of year 5, and so on. And that's why we'll have a formula. But why I wanted to show you this is the formula we're fixing to use. That's what it's doing. It's doing this for us. And we just have to plug it into that formula, and it's a lot simpler. But this right here is the idea of the annuity. All right, so now that's part A. Now for part B, they want us to find the interest. So how are we going to find the interest? Well, the interest is going to be this total amount here that we got at the end of 3 years minus what we put in. So how much did we put in? Okay. How much did we put in to the savings account? All right. Well, we deposited $1,000 at the end of each year for 3 years. So we did that 3 times. So 3 times 1,000 is equal to $3,000. So the interest is equal to this amount here, the $3,246.40 minus the $3,000, which is going to be $246.40. And so that would be your interest. All right. So now let's come down here, and thank goodness we don't have to work the problems like that anymore. That's just to give you an idea of what's actually going on. Well, now we have a formula. So the value of an annuity, interest compounded once a year. Okay. So if P is the deposit made at the end of each year for an annuity that pays an annual interest rate R, and R is in decimals, compounded once a year, the value A of the annuity after T years is A equals P times 1 plus R to the T minus 1 divided by R. So let's look at this. It says, suppose that when you are 35, you decide to save for retirement by depositing $1,000 into an IRA at the end of each year for 30 years. If you can count on an interest rate of 10% per year compounded annually, how much will you have from the IRA after 30 years? And find the interest. All right, so the best thing to do when you're working these is write the formula down. All right. Okay. So there's our formula. So what we need to do is we need to know what P is, R, and T. Okay. So in this problem, well, P, that's our deposits at the end of each year, which is 1,000. Okay. Now we need R. Well, R is, that's at 10%. So remember how to convert percent to decimal. You just move it 2 places to the left, so that's 0.1. And then we need T, and in this case, that's for 30 years. And then all we do is we just plug this in. And so we're going to get A is equal to P, which is 1,000, times 1 plus R. R is 0.1. And that's raised to the T, and T is 30. And then that's minus 1 over R, which is 0.1. And so we get A is equal to, and when we punch all that into our calculator, we get 164,494. All right. And so that would be your answer. That's how much you would have after 30 years. And this is part A. All right. So now they want us to find the interest. So for part B, the interest is the amount we have after interest and everything. So that's 164,494. That's just like the last one, like in example 1, finding the interest on that. Now, what did we do? We did $1,000 for how many years? 30 years. And so that's going to be $30,000. And so minus, that's how, this is the amount of money, this 30,000. That's how much money we actually put in. And so when we subtract that, we end up with 134,494. That's the interest that we made. Okay. So you can see that's quite a bit more than what our actual payments were. So you can see how this can be very beneficial. All right. Now, that formula there that we use, this one right here, okay, that's for the value of an annuity. Okay. You don't need to memorize it. Okay. This is for interest compounded once a year. Well, now we have a formula because our payments don't necessarily have to be at the end of each year. We can make monthly payments. We can make quarterly payments. We can make payments every 6 months, every week, or whatever. Okay, so how would we go about doing that? So if P is the deposit made at the end of each compounding period for an annuity that pays an annual interest rate, or in decimal form, compounded n times per year, the value A of the annuity after T years is this right here. So you can see that this looks similar to the formula we just looked at. Okay, so keep in mind what that formula looks like that we just used, and that formula that we just used for example 2, this one right here, you don't need to remember that. The only thing you need to remember is this one. Okay, and let me show you why. So let's go ahead and write this. Okay, let's rewrite this formula. Now, if you remember what you've learned so far is you should have learned compound interest by now. And you know if it's compounded quarterly, N would be 4. Compounded monthly, N would be 12. And so on. Okay, compounded semi-annually, N would be 2. Compounded annually, N would be what? 1. So that would be R over 1, right? If it was compounded annually. 1 times T minus 1 over R, right? So all I'm doing is showing you how you can get that formula we just used for compounded annually from this one. So all I did, if it's compounded annually, N is 1. So all I'm doing is replacing the N with a 1. Whoop, sorry. And that's over 1. And so this just turns out to be P times 1 plus R over 1 is just R. 1 times T is T minus 1, right? And R over 1 is R. So you can see this formula right here, that's the formula we just did. So that's why I'm telling you, don't worry about remembering that formula that we just did. Just remember this one. Okay? So why show you that one? Well, I mean, really all it does is just saves you from plugging the 1 in. That's all it does. Okay? But this part right here, going from this R over 1 and just writing R, you should be able to do that in your head. Okay? So let's go ahead and look at another example. So at age 25, to save for retirement, you decide to deposit $200 at the end of each month into an IRA that pays 7.5% compounded monthly. Okay? How much will you have from the IRA when you retire at age 65? Okay? So, and then find the interest. So this is an annuity. We have equal payments at the end of a time period. This is at the end of each month. So this is an annuity. So first, just like in the other problem, let's write the formula down. So I have A equals P times 1 plus R over N raised to the NT minus 1 over R divided by N. Okay. Now, we've got to figure out what P, R, N, and T are. Okay. So, first, let's look at P. So, P, that's our equal payments, right? All right, so that's $200. That's at the end of each month. That's from here. Then let's get R. That's 7.5%, so that's 0.075. Let's get N, compounded monthly, so N is 12. And then I need T. Well, let's see. At the age of 25, it doesn't come out and tell us for this many years, does it? But it does say for T, how much will we have when you retire at age 65? Well, when did we start? We started at age 25. So T would be 65 minus 25, which is equal to the 40 years. Okay. So now let's plug all this in. And by the way, this is part A. So we have A is equal to P, which is 200, times 1 plus R, which is 0.075, over N, which is 12. And all that's raised to the N times T, and then minus 1, over R, which is 0.075, over N, which is 12. And so in this case, we would have $604,765. Okay. All right. So then what they want to know is find the interest. Okay. So for part B, let's find the interest. So just like in the other problems, it's going to be this amount minus how much money we actually put in there. Okay, so how much money did we put in there? Well, we put $200 in there at the end of each month. So that's $200 at the end of each month. So that would be times 12 months in a year. And we did that for what? 40 years. So that would be times 40. All right. And so that is equal to $96,000. That's how much money we put in there total. 200 times 20, times the 12 times the 40 is 96,000. So the interest is equal to the 604,765 minus the 96,000. And so our interest would be $508,000 and $508,765. And so that would be our interest. And that's more than what? That's more than 5 times the amount that we put into the IRA. Okay. All right. So we got a note here. Ordinary annuities. Those are we have ordinary annuities and we have annuity due. Okay. So the ordinary annuities, that's payments made at the end of each period. That's like the problems we've been working. The payments were made at the end of each period. And then we have an annuity due. Payments are made at the beginning of each period. So like in that first example, when we made the payment at the end of each year, what you would do is you would have made the payment at the beginning of each year. And that amount would have been a little bit different. All right. Now we have regular payments needed to achieve a financial goal. So the deposit P that must be made at the end of each compounding period into an annuity that pays an annual interest rate R, and R is in decimal, compounded N times per year in order to achieve a value $8 after T years is P equals A times R over N divided by 1 plus R over N to the NT minus 1. All right. So what this is doing, this is saying, okay, well, let's first recap what we just did. So what we just did is we made payments at the end of each period. And we said, okay, how much am I going to have 10 years, 40 years from now? Okay. Well, what this one's doing, it's saying, okay, 40 years from now, I want $500,000. How much do I need to put in a savings account every month to have that? And it's getting interest and all that stuff. Okay, here's your formula. Okay, now to make it easy on yourself, you don't have to memorize this formula either. So far, the only formula that needs to be memorized is this one right here. That's it. Okay? So let's look at this and let me show you. I'm going to show you right here. So if we take our formula, let's take A equals P times 1 plus R over N to the NT minus 1 over R over N. Okay? That's the formula for our annuity. Now, remember, this is P times this, right? P times that. So we can actually do this, can't we? P times all of this right here. You see that? Well, if you think about this, look, when you have, say, I don't know, maybe 10 equals, say, 5 over 6 times x. Do you remember you can multiply both sides by 6 over 5 by the reciprocal of this number here in front of your variable, and that makes this a 1. Okay, well, look, that's all that's happening here. All this is P is equal to, and what I'm doing is I'm multiplying by the reciprocal of this thing. So all I'm doing is I'm flipping this. You see that? This R over N comes up into the numerator, so that's A times R over N. And then this part right here comes down to the denominator, 1 plus R over N to the NT minus 1. And you can see that's that formula right there. So no, you don't have to memorize this. I mean, you can, but if you just remember this one, you can get everything from that. All right. So let's look at this. So suppose that once you complete your college education and begin working, you would like to save $20,000, okay, over 5 years to use as a down payment for a home. You anticipate making regular end-of-month deposits in an annuity that pays 6% compounded monthly. How much should you deposit each month? So that's part A. And part B, how much of the $20,000 down payment comes from deposits and how much comes from interest? All right. So, once again, look, write your formula down. Write the formula down. So that's P is equal to A times R over N over, and that's going to be 1 plus R over N to the NT minus 1. Okay. So let's go ahead and state everything we have. So I need A. Now remember, in this case, A is the amount of money we want so many years from now. So what it's saying is we would like to save $20,000 over 5 years. So at the end of 5 years, we want $20,000. So A is $20,000. Then we need R. So R, well, here it tells us that it pays 6%. So that's 0.06. And then we've got N, and let's see what kind of payments. See, where is it? Regular end-of-month deposits, compounded monthly. So monthly N would be 12, and then T, well, there it says we want to do it over 5 years. So T is 5. So now we just plug this into our formula. So I get P equals, so that's going to be 20,000 times R, which is 0.06 over N, which is 12, divided by, that's going to be 1 plus R, which is 0.06 over N, which is 12. And that's raised to the N times T, so that's 12 times 5, and then minus 1. And so, let's see what that comes out to be. That comes out to be $287 at the end of each month. That's how much money we've got to put in at the end of each month, and then you'll have $20,000 in 5 years. And once again, this is part A. Now for part B, okay, part B, it's wanting to know, let's see, how much of the $20,000 down payment comes from deposits and how much comes from interest. All right. All right, so it's going to be what? It's going to be the $20,000. That's how much we're going to have at the end of five years. Well, how much money did we actually put in? Okay, how much did we put in? All right. Well, we put in $287 a month times 12, and we did that for 5 years, and that ends up being $17,220. This is the amount of money that we actually put in, but with the interest and everything, we ended up with $20,000. So we subtract the $17,220, and that gives us $2,780. Okay? So you save $2,780 in 5 years. All right. So stock. Shares of ownership in a company. Okay, that's what stock is. Shares of ownership in a country. So for an example, company issued a total of 1 million shares, and an investor owns 20,000 shares. So the investor owns the 20,000 shares divided by the 1 million shares, so that means he owns 2% of the company. Okay, so what we're going to look at here is we're going to look at stocks. It's not by any means is it going to be anything in depth. This is just something, kind of quick. Not going to go into a lot of detail about it, but let's just look at this stock table here and just kind of run through it. So there's a couple of questions I'm going to ask. I don't have them written down, okay? I'm just going to ask a couple of questions. You think about it while I'm asking them, and I'll write the answer down. So for the first question, we want to use this stock table here. Okay, this is a stock table for Disney, and we want to answer some questions. So what were the high and low prices for the past 52 weeks? Okay, well, that's easy enough, right? Okay, so the high would be what? That would be the 42.38. That's here, and the low would be the 22.50. All right, that's the high and the low. Like I said, I'm not going to get into a lot of depth on this stuff. Okay, so let's look at another question B. If you own 3,000 shares of Disney stock last year, what dividend did you receive? Okay. So to find that, you look under the dividend heading. All right. So the price is listed in dollars. Okay, it's listed in dollars, so that's 0.21. All right, or 21 cents per share to stockholders last year. So let's suppose, and it says you owned 3,000 shares. Okay, that was in the question. If you own 3,000 shares, okay, you received a dividend of 0.21 times the 3,000, which that is going to be $630. Okay. Now, as I'm going through this, if you want to, you can write the questions down when I read them. I mean, you've got the option of pausing and rewinding the video, so just write the questions down. All right. So for part C, what is the annual return for dividends alone? How does this compare to a bank account offering a 3.5% interest rate? All right. So what is the annual return for dividends alone? So we find the annual return for dividends alone, we look under this column right here. Okay. All right, so that's the percent yield. So what we have in there is we have 0.6 is a percent. This means the dividends alone gave Disney investors an annual return of 0.6%. Okay, that's the annual return. And they're wanting to know, how does this compare to a 3.5% interest rate? All right, well, that's a lot lower than a bank account paying a 3.5% interest rate, right? But however, Disney shares increase in value. The gain might make Disney stock a better investment than the bank account, okay? Because the value, it could increase in value, and that might outdo the 3.5%. Okay, I mean, like I said, I'm not getting into a lot of detail on this stock stuff. I'm by no means an expert in business or anything. Just kind of touching on some things. Okay, so hopefully that kind of gives you an idea of some of the things in a stock table, and this right here, this shows you the high and low for yesterday. Okay, that's what that is, the high and low for yesterday. This right here is at close. That's what the stock is at close, and then the three bars here on net change. That means that there was no change in price in Disney stock from the market close 2 days ago to yesterday's market close. Okay, so like I said, that's just a quick, rough thing on a stock table. Okay, if you want to see more detail on that, you might want to search YouTube for how to read a stock table, because I'm not anyone to teach you about that, but hopefully it just kind of gets you familiar with it. The book that I'm doing this out of has stock tables where they want you to read it, so I just went over that real quick. All right, so let's look at this example 6. All right, it says, suppose that between the ages of 25 and 35, you contribute $4,000 per year to a 401k, and your employer matches this contribution dollar for dollar on your behalf. The interest rate is 8.5% compounded annually. What is the value of the 401k at the end of 10 years? All right, so this is part A. This is a 2-part question. There's a part B down here. All right, so that between 25 and 35, you contribute $4,000. All right, so we're making $4,000 per year, so that's how much is going in at the end of each year. Okay, And we want to know how much are we going to have after 10 years. So that's what? That's an annuity, right? So let's write our formula down. So we've got A is equal to P times 1 plus R over N to the N times T minus 1. And look, if you recognize this, okay, if you recognize this, you know this is what? This is compounded once a year, so you know N is 1. And when you're writing your formula down, if you wanted to, you could just write that down. Okay? All it is we're changing the N to a 1. That's it. Okay? But like I said, if you don't want to remember all that, just remember this formula here that I have written down. All right. So we need P. All right. So P, that's how much that's being put in at the end of each year. So in this case, P, that's 8,000. All right. So I want you to sit there. I want you to think a minute. Pause the video and think, how did he get P to be 8,000 when he says 4,000 here? Okay. Well, yeah, it says 4,000, and your employer matches this contribution dollar for dollar on your behalf. So the employer's putting in 4,000 also. So that means there's a total of $8,000 going in. All right. And then we need to know what R is. Well, that's 8.5%, so that's 0.085. We need to know N. Well, N is 1. And then T, well, we're doing that from age 25 to 35. They didn't even have to give us that, but 25 to 35, that's 10 years. And so now we just plug everything in. So A is equal to 8,000 times 1 plus, and this is R over N, so it's 0.085 over 1, which is just 0.085, okay? And then N times T, so 1 times 10 is 10, and that's what I was talking about. I mean, just go ahead and do this part in your head. Minus 1 over R over N, so 0.085 over 1, which is just 0.085, and so that is going to be $118,681, and there's your that's the amount there. All right. So after 10 years of working for this firm, you move on to a new job. However, you keep your accumulated retirement fund in the 401k. How much money will you have in the plan when you reach age 65? All right. So now we have to switch gears here a little bit. Okay? So we've moved on to another job, and this money right here, we're going to keep in the account. Now, keep in mind, we're not going to make any more payments into that account. Okay, it's just starting off with the 118,681, this amount right here. But that's going to accumulate interest. So this goes back to something that you've learned earlier. If you're at this point, then you've learned compound interest. So we've got A is equal to what? P times 1 plus R over N to the NT. Or you got what? A equals P times 1 plus R to the T. Okay? Doesn't matter. Okay? If you watch my video on compound interest, you know that's the only one you've got to remember. Okay? Because N is 1. Remember, this is compounded yearly, once a year. Okay? So we've got to figure out what all these values are and plug them into the formula. So basically, we're finding how much are we going to have with this sitting in an account. Okay, this is just sitting in an account. So how much interest is it going to accumulate over the rest of the time until you're 65. All right, so here we've got P is equal to, well, let me bring that down a little bit. That's 118,681. Okay, that's this amount here. That's what it's starting out at. And then I need R. R is still the 0.085. I believe that's what it was. Yep, 8.5%. And then I need N. N is 1. And then we need T. All right. So let's see. It's until we reach the age 65. But when does it start? Well, this scenario here with the payments, that was from age 25 to 35. So from age 35 to 65, that is when this kicks in, this problem. So we know that 65 minus 35 is equal to 30, so that's for 30 years. And so now I plug everything in. So A is equal to the 118,681 times 1 plus R over N, which is just 0.085, to the N times T, which is 30. And so A is equal to 1,371,745. All right, so there's that answer. And then look at here, there's a part C too. What is the difference between the amount of money you will have accumulated in the 401k at age 65 and the amount you contributed to the plan? All right. So we did what? What did we contribute? We contributed $4,000 per year to the 401k for 10 years, right? All right. So we did the 4,000, okay, and we did that for 10 years. So that's times 10, and that equals 40,000, right? So the difference between the amount that you accumulated in the plan, which is this one, and the amount you contributed, that difference, all right, that's what they're looking for. They want to know the difference between that. Now, I know one thing you might be thinking. You might be thinking, well, the payments were $8,000 at the end of each year. And that's true, they were. But remember, only 4,000 of it was the amount that you put in, and the other 4,000 was the employer. So remember, what it asked is, what is the difference between the amount of money you will have accumulated, okay, in the 401k at age 65, and the amount you contributed to the plan. So we only contributed $4,000 per month, and so that would be, the difference would be 1,371,745 minus the 40,000, and that turns out to be 1,331,745. Okay, so you got a lot of money and didn't put a lot into it, right? You only put 40,000 in there, and you got about 1.3 million, a little over 1.3 million. Okay. All right. So, last example here. All right. So here are two ways of investing $30,000 for 20 years. We can have a lump sum deposit. Okay. Lump sum deposit. $30,000, 5% annually for 20 years, or we can do $1,500 at the end of each year for 20 years, at 5% annually. Okay, so notice it says here are two ways of investing $30,000 for 20 years. So you can put it all in. Okay, so remember that's 20 years, or the 1,500. Now remember that's 1,500 times the 20 years. That equals the $30,000. This is still depositing $30,000. It's just doing it in a different way. All right. So what we're going to do is we're going to look at these two scenarios and just compare them. Which one's better? So after 20 years, how much more will you have from the lump sum investment than from the annuity? Well, okay, so that tells us right now, just the way they're asking the question, the lump sum's going to be better, right? So let's go ahead and get that. So the lump sum, okay, now this is compounded annually. So let's write our formula down. So we have A is equal to P times 1 plus R over N raised to the NT. All right. And in this problem, we've got P is equal to the 30,000. Okay. We're working right now, we're working the lump sum deposit. Okay. So that's P. R that was 5%, so 0.05. And N, that's compounded annually. T, that's for 20 years, so that's 20. So I'm going to get A is equal to the 30,000 times 1 plus R over N, so that's 0.05, raised to the N times T is 20. And so that gives me A is $79,598.93. Okay, so that's how much I would have at the end of 20 years if I just put $30,000 in there in a lump sum. All right, so now they want to know, now we want to look at this scenario here where we make $1,500 payments. Okay, so what I'm going to do is I think I am going to write that amount right down here. So that's the 79598.93. That's from the lump sum deposit. So let me erase this so I can work the other part of it. Now we want to do the payments. So once again, just remember, whenever you're doing this, you want to write the formula down. So I have A is equal to P times 1 plus R over N to the NT minus 1. And that's over R over N. So here I get P. Well, the payments, remember, those are $1,500. R, that's my interest, 0.05. N is 1, and T is 20. And so I get A is equal to 1,500 times 1 plus R over N, which is just 0.05, raised to the NT, which that's 20, minus 1 over R over N, which is 0.05. And that comes out to be 49598.39. Okay. So you can see that's quite a bit of difference. Okay, that's quite a bit of difference. So it says in part B, and let's write this down, that's 49598.39. All right, so after 20 years, how much more interest will you have earned from the lump sum investment than from the annuity? How much more interest? Well, to do that, we've got to figure out how much interest we earn from this and how much interest we earn from this, and then subtract those two. All right. So So interest, let's do this. Interest from lump sum. That's going to be the 79,598.93, right? Minus, now remember we put in $30,000, right? That's how much we put in each of them. This was just a lump sum payment, and the other one was payments every year. And so the lump sum payment, that's what, 49,598.93. And then we need the interest from the annuity. Well, that's how much we got from the annuity. That's the 49,598. Wait a minute, is that 39? Let me double check that. That might be 93. Yeah, this right here, I'm sorry about that, but this right here, that's 93 cents, not 39. I just wrote them backwards. Honest mistake. So yeah, that's 93 cents. Minus the 30,000. Okay, so I hope everybody understands where I'm getting the 30,000 from. The 30,000 on that's coming from the 1,500 times the 20 payments equals the $30,000 that we put in. All right, so this is going to be what, 19,598.93. So how much more interest will you have earned from the lump sum investment? So that would be what, the 49,598.93 minus the 19,598.93, which that's going to be, so that's quite a bit. You earn $30,000 more by putting it all in a lump sum. Okay, so I know this video was long, but I hope it helped. I hope it made sense. Hope you feel a little smarter now. So go check out my other videos. Give me a like, share, and subscribe. And thanks for watching.